He co-authored Prototype JS, and he wrote many best-selling books on JavaScript. These days he does consulting and also writes JavaScript, I guess.
Yeah, most of training too.
Training as well. And he lives in Paris, and he is about to tell us why we should be using ES2015, which is 2015 actually. We should be using it last year. So take it away.
Buongiorno a todos. Je m'appelle Christophe, che sono rimasto a Parigi. E mata a hea ελληνικά στο σχολείο. Αλλά δυστυχώς δεν γνωρίζω τα ελληνικά που μιλούνται τώρα. Όποτε καλύτερα εννοήσω στα αγγλικά. Was that any good?
Yes.
Thank you. Okay. Good. Okay, the hot pot's over. So, yeah. I should focus this. Right. Hi. So I'm Christophe. And I'm pretty much 39, which makes me a dinosaur by web standards. And yeah, so I live in Paris. Got a company called Digital Insights. I do a lot of stuff in JavaScript. I've been doing professional JavaScript for 21 years now. And just a short reminder, and I'm going to go super quick because the WebAssembly talk already covered this, but basically JavaScript is it's like 21 years old now. It's out of the house, it's on its own. And unfortunately, it was called JavaScript, right? So everybody thinks, like half the HR departments in the world thinks it's the same as Java. And it's not, which is why you want to go to DevOps or Voxxed. I mean, pagan territory, actually. You know, I have to sort of like preach outside of the choir. And ES5, or actually most of you probably use ES3. Does any of you intentionally use ES5 specific features in their code? Like property descriptors or stuff like that? No, you don't. So actually what you write is ES3, which I like to call ES1999. And this is 2016. So the language, admittedly, has evolved very slowly, not as slowly as Java, but very slowly. I'm going to troll a bit, that's fine. I've done millions of lines of Java in my time, which is about what you need for a hello world application, but it was a very long time ago, and this is a path that I'm not going to walk back to. I would like to express my sincere sympathies for anyone who is ever going to attempt the JDK9 modular thing. Stay with OSGI, please. It doesn't look really simple. Yeah, like, you know, Word. Anyway, so ES2015, the thing with every new web standard technology is that we have this historical belief, which was true, that, I should stay in the light, which was true, that it's not there yet. And that we're gonna have to wait forever. You know, because who here has or had to support IE6? Or had, yes, had works as well. So few, you youngsters, you know, you kids. And because of that, we're like, yeah, you know, it's like only 2 years old, well, 1.5, so it's going to be there like maybe in 5 years. And that's actually not how it works anymore. When a version of ECMAScript, which is the official standard for JavaScript, goes out, it's already massively supported now. Let's just talk about ES2015, but ES2016 is pretty much the same story. It is currently at 90 to 98% support in all the evergreen browsers. And that's also Safari 10. Until Safari 10, Safari was like the new IE6, right? And it's slowly getting better. They're getting their shit together. Still have a lot of work to do, especially in the web API departments, like service workers and everything. But that's finally coming together. And in Node, Node rocks. In Node, especially since Node 6, which is the current LTS, so the long-term support version, it's 96%. 97 actually, in the latest 6.9 LTS release. So, and the 3% we're talking about that are not there, we don't give a flying fuck about. Like, they're like single species, we don't care. So, what do we have to do though, especially on the browser side, because you probably still have support like IE9, you know, probably IE8 as well. And even if it were just IE11, that wouldn't matter because they don't have ES6. So how do we do? First, why do we say ES2015, right? Because you heard about ES6, right? Well, the thing is, when you talk in terms of versions like this, there are two things that happen. First, now we have a new version every year, like for real, right? Like in March every year, whatever is ready ends into the spec, and by June, the standardization process is complete and it's published as a new version. So it's a yearly thing, so we put a year on it. Also, when I tell you, oh, you're still coding in ES3 and it's ES6, you go like, oh, you know, it's not very far back, it's just 3 numbers. When I tell you, you're coding in ES1999, some of you were in junior high in 1999, or maybe even elementary school, you know? So that seems kind of dated. You know, like a web generation is like 2 years. So, so there's a marketing thing to it as well. Now, when you have to support platforms where they have only parts or not anything about the JavaScript you want to use, you can use Babel. Babel is the best thing since sliced bread. Babel has become a totally critical part of the infrastructure of the web. I mean, most of the large web companies, Facebook, Airbnb, whatever, they're massively reliant on Babel. Facebook actually hired the entire Babel team. So the entire code base of Facebook in JavaScript, which is about 8 million lines, is entirely ES2015 plus transpiled by Babel. So what Babel does is that it takes ES2015, but also 2016, 2017, and even stuff that is currently just like a simple idea, like what we call stage 0, right? Which is pretty much like, I got an idea, and that's it, right? And turns it into ES5, if they can. And they can do that for pretty much everything except something called proxies. And if you have ES5, you're golden. And that means that on the browser world, that's everybody and IE since IE9. So that's already pretty wide. And on Node, obviously, that means every single node ever, right? Even like Node 0.1. So you're good to go. And it integrates with everything. You've got Babel integrations. I'll give you the links to those slides. You've got Babel integration with every single tool, IDE, builder, editor you can think of. Okay, so it's really, really massive. So why do we want to do ES2015? And I like talking about this, especially in a Java crowd, because you're like at a Voxxed or Devoxxed or Microsoft Experiences conference, they come from other languages. And traditionally, when you come from more traditional languages like Java or Python or Ruby or anything, entering the JavaScript world pre-ES2015 feels weird. Like there are prototypes and prototype chains, and this is weird. And mostly that's because you don't read the docs. But you know, if you do read the docs, you're in the world's top 1% developers. Like that. Time for a raise. So it's kind of weird. It works in a way you're not used to. And ES2015 adds a lot of syntactic sugar to make it look more familiar when you come from, say, Java or Python or C#. You know, ES2015 is going to be easier because of that new syntax. It's going to be more powerful because it means it's getting easier to do powerful stuff, so you actually do it. It's going to be more reliable because it just tightens the screws on a number of potential security issues and also anti-patterns that we knew in the JavaScript world that are now syntactically invalid. It's going to be more performance, especially because it delegates a lot more stuff to the native runtime. And then with Babel, the ES5 code that Babel outputs is usually more performant than your own code. Generally, it's just more fun. That's reason enough right there. Because that JDK9 thing doesn't look fun. Come over. Okay. So, objects and classes first. Okay, so you know object literals when you used to have to do stuff like name, colon, name, comma, ID, colon, ID, comma, age, colon, age, comma, all the time. When you have a key like that whose value is a variable with the same name, you can shortcut that. It's called the property shorthand notation. And you can just put the names like this. This is all from actual production code, by the way, stuff we do in our trainings. And that's just like super short, super neat. That's just way easier. You actually use that all the time. There's also something in traditional JavaScript when you had a property whose name was dynamic and you needed to read or set it, you could not use the dot operator, that's static. You had to use the square brackets, but if you created an object maybe to return it, You have to first put it in a variable, then use the square brackets to add the dynamic properties, and then return it. You don't have to do that anymore. You can use the square brackets inside the literal, and with any expression in there. And I mean any expression. Like you could make a map call in there. You know, that's okay. It just works. It's gonna look fugly, but you can do it. Classes, yay, we have syntactic sugar for all the guys who say, oh, JavaScript is not object-oriented, I didn't see class. Yeah. So I'm not going to enter that debate because I would troll to no end, but we finally have syntax that makes you feel all warm and tingly. That does not add any single capability to the language. It is exactly the same thing under the hood as traditional JavaScript classes. But you have class, you have extends, you have constructor, you have super calls, like this for a constructor, and we'll see in the next slide for inherited methods. There are a number of things that are stricter here. New classes are automatically in strict mode, so there are a lot of stuff that becomes like invalid, like bad practice in your code that becomes invalid syntactically. I mean, your JavaScript file will not even parse if you do that inside class bodies. There are also a few anti-patterns. For example, if your class extends another class and you make your own constructor, you have syntactically to call the inherited constructor, and you have to do that before accessing this. Otherwise, it's just syntactically not valid. We have what we call concise methods, which is short notation for properties that are functions. Instead of saying like handle double click, colon, function, parenthesis, you just go handle double click, parenthesis. Okay. And there are a few things you can do in there. This actually works in object literals as well. You can do that, and so you can have like super calls in there, and they're automatically named. A lot of good things in there, and that looks way more familiar when you come from a traditional OOP class language. Suddenly you go like, oh, that's not so bad. I can do that. We have static, obviously. We have very short syntax for getters and setters. That's something that Java sorely lacks, but that you have in C# and Python and Ruby and everything. Like transparent accessors for properties. So it looks like a property, you don't use parentheses, but under the hood it calls functions, so you can have like computed properties that are completely transparent. You can have stuff that starts as data properties and becomes computed properties, and your API doesn't change. And it used to involve like a very verbose property descriptor call you would do in ES5, and now you just prefix the getters and setters with get and set, and that just works transparently. That's very neat. So we have this is all syntactic sugar. This is all stuff you could do before, but it was verbose, it required expertise. Now it's much more familiar. We have a lot of extra comfort in the syntax, and that's getting really cool. We have destructuring. Destructuring can really quickly get messy if you destructure recursively like a madman, but it's extremely useful. We can grab an object and grab specific properties in that object, and instead of having to do manually like const x equal opt x and const y equals opt y and everything, you can just, around your declaration, you'll add the curly braces because you're destructuring an object, and there you go. You can, let me just run mouse pose on this. There you go, here, right? Okay, so and you can do that for arrays or any kind of iterable, really, using the square brackets. And you can even skip positions, like filters here is going to be position 1, not position 0, because I skipped with the first comma. And you can do that recursively. You can do that for arguments. So you can have like an argument which is like a large options argument and immediately destructure it. And your signature is more readable. Instead of saying just options or stuff like that, it tells you exactly what it's interested in. And so tools that do completion can use that to inform you on the shape of the required options. So that's element A. That's what I call my holy trinity. Element A is destructuring. Element B, well, that's still destructuring. So you've got an example here in Node. You've got an example of actual useful nested destructuring here in the middle example. So this only introduces 4 identifiers: name, units, progress, and target. We don't see goals or stats in there. Okay. You have like a promise all in there where it returns an array, so I destructure that array into identifiers which I can then use as short tags. So that just cuts the volume of your code enormously. Second part of the Holy Trinity is rest and spread. So you've got some of that in Java for the Java guys among you, but not all. In JavaScript, it's prefix, not suffix. So it's dot, dot, dot. And if it's in a declaration, it's a rest. So that means that you're saying, okay, from this point on, however many arguments are still left, or however many array items are still left, let's turn that into an actual array. Okay? You might know, I hope, that in JavaScript, the amount of parameters you declare in a function is just a hint. You can pass any argument list you want. Okay? And so here, for example, winners has boss, real boss, and everybody else. And so you pass in Zeus and Hera and Metis and Themis and Leto, and it will tell you that, okay, boss is Zeus, real boss is Hera, obviously. And so the containers would be some of these other spouses, because that guy had a lot. That's one of the privileges of being a god. And so you can see that's what we call a rest. You can do that in array destructuring or in argument destructuring. And we also have spread. That's the same syntax, but in expressions. And that's saying, okay, I've got something which I can iterate over here, and I want to actually explode it in all the individual values. For example, I can push on an array, and push takes individual values. If you pass an array, it will take the array as a whole and put it as one single cell. And I want actually to use that array, but as individual arguments to push. So they actually get concatenated at the end of the first array. And I just spread array 2 in the call, and that's like my saying, okay, argument 1 is first item of array 2, argument 2 is second item, and so forth. And you can do that, as you see at the bottom, node list. I'm actually missing some code here. Yeah. The node list as array. That's actually a way to turn anything that is iterable into an actual array. You just spread it, and then you wrap it with brackets, so it becomes an actual array. So this is like a node list that turns into an actual array, so I have all the array methods on it. So you don't have to do, for those of you who did stuff like array prototype slice call x, you can just do square brackets dot x, that's the same thing, but shorter. Now in ES2017, which is the one released in next March, we also have object, spread, and rest. So we can use that on object literals, and that's sort of like $.extend or object assign, where you can just like create an array, create an object out of other objects that overwrite each other, but it's much more concise, you know. So to take an episode from the War of Troy here, Helen used to be with Menelaus, right, in Sparta, and well, her mother is Leda anyway, so stay Leda. But she got kidnapped, right, by Paris, who took her to Troya, and hence the war. Like, and not the one single war in Greek mythology, right? And so if I just use a spread inside a new object, so the order is important, and at the end of it, obviously, rel and lock are going to be overwritten, but stable is going to overwrite as well, stuff we had earlier. So that's a bit more concise than calling the object assign or $extend. You don't have to put as many curlies. It's just nicer, it's shorter. And the final element of the Trinity would be default values. So we have default value syntax now, which you can use in argument lists and in destructuring. And that default argument is going to be only ever called if the original value is missing or undefined. If it's false or null or 0, it's going to be kept, even null, right? It's going to be kept. Undefined or no argument passed, it's going to be triggered. Now the really cool thing about those default values in argument list is that they can actually be expressions, like very complex expressions, that can be based off other arguments earlier in the list. They can even be function calls. And those functions are only going to get called if the argument is missing. So you can have a function called like required, where you put the argument name, which would throw an error, effectively making the argument required. You know, you could do anything with that. You could log it, for instance, in the function or anything. That's pretty cool, and you can do that in the structuring as well. Those three items, the structuring, default value, and rest and spread, are basically present in every other line of idiomatic ES2015 code. I mean, you use them all the time. When you switch to ES2015, you will notice that you do not do that enough. Actually, you still stay in a lot of like old patterns. And the more you revisit your code as you grow into ES2015, the more you'll go like, oh, I could have destructured here, I could have done that, and just improve it. Template strings. So strings in JavaScript are kind of weird. Internally, they're exactly the same as Java. They're UCS2 encoded. JavaScript has a bit of a peculiarity, though, is that the two delimiters for strings, single quotes and double quotes, are actually exactly the same thing. There's no like, oh, it's single quote, so you cannot use \n or whatever. It's exactly the same thing. But they have issues. They are not multi-line. You cannot easily just go to the next line and keep going. You know, it doesn't work properly across all the engines. And you cannot interpolate. You cannot inject dynamic pieces in there. So you have to do like plus, 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 and not miss the spaces and do. I mean, even PHP does that properly. Like PHP, right? So that's like shameful. So we have a new delimiter, the backtick, right? Or back quote, same thing. Super easy on Mac, it's right there. I'll add graphic, whatever, for the poor PC users. And within those backticks, you can go as many lines as you wish. Every single character is going to be kept. Indentation is going to be kept as well, be careful. Every single character between the two backticks is going to be kept. And you can use $curlies to interpolate any expression. It's going to be turned into a string in the end, but it can be any expression, however complex. So that's kind of neat. There's also something for the people among you who have looked into ES2015 called tagged template string. It's kind of sweet, but that's very advanced. I don't have time for it in this talk. So look online if you're interested. Let and const. So we're that language who's very excited that in 2015 we've got const. So the thing is, usually in JavaScript you had only two declaration keywords, which were var and function, right? Function. Usually people forget function. Like, oh yeah. Var has a weird behavior, is that var is hosted. You know, wherever you declare your var, it's actually as if you had declared it at the top of the function without initializing it. That's usually an issue for loops that use asynchrony or stuff like that. Because the variable is actually, if you use var, the variable is actually outside of the loop, it persists outside of the loop, it's shared across all the closures. And you don't want that. You don't really need ever for the variable to be hosted. You declare it where you need it, and that's it. Plus, most of your variables are actually not variable at all. You initialize them once, and that's it. You don't reassign most of the time after the fact. So we have two new keywords, const and let. They are both block scoped. That is, the scope is not the function, the scope is the block, right? The most closed curly braces, and even the block, there's an implicit block for the for loop, right? You don't even have to have the curlies. Every single turn of the loop has its own implicit block. And put the curlies, save yourself. But you don't need them, technically, for that block. And so we say that const is the new var. You should use const by default, so that most of the time if you reassign something and it will yell at you, because you can't, probably it's because you made a typo or the completion was not right. And if you wanted to reassign, change it to a let. Okay? Let's start with const and use let. Do not ever use var ever again. Okay? There are some subtleties as well about the global object and stuff, but I'm not going to get into that. Const does not mean immutable. It just means you cannot do x equal something again. Okay? But if your value is structured, if it's an object or an array, you can change it however you like. You know, as long as you don't say x equal again, it's considered constant. It's not the same thing as like deep freezing an object, right? You've got modules like deep freeze, to original name, to do that. But it's just saying you cannot do like days equal something again. That's all that const does. And it allows for optimizations by the runtime, by the way. We also have some extended littles. So, fun fact, base 8 octal numbers were never officially part of JavaScript, ever. It's just one of those things when JavaScript and JavaScript kept fighting during the browser wars at the end of the 90s. They added it on their own, you know, like an extension, proprietary extension, but this was never sanctioned. And the thing is, a lot of people do not realize that if your number starts with a 0, it's base 8. And sometimes they align numbers by using zeros. So they think it's 52, but it's 42, right? And so in strict mode, you can't do that. But now in ES6, we do have official syntax for base 8 and base 2. So it's 0, 0, If you're an asshole, you're going to use an uppercase O, right? And 0B for binary. The only thing we miss now is something I think you have in Java 8 and that Ruby pioneered, is like the ability to put underscores anywhere in the numbers so that you can see the groups, right? That's something I'd really love to see, but it's not there yet. There's also something about Unicode. So Unicode covers every known language, including the fictional ones, right? Unicode has emojis, like the smiling turd, or the juggling snowman. And Unicode has Klingons and Silverings and troll languages and everything, and it has actual languages, fortunately. This is a Japanese kanji. Does anyone know what this is? Sort of like good fortune, luck, happiness kind of thing. And that kanji, like most of Asian languages, is actually way beyond the first 16 bits of the Unicode codes, what we call a code point. And so JavaScript, just like Java, characters in the strings are UCSC codes, so they're just 16 bits. So when you start having a kanji that is, well, a character, a code point that is beyond that scope, it has to split it into two invalid characters. You can see the two codes on the second line. And so that's, even the \u syntax only covers 16 bits. So we have a few things to deal with that, because that can be a problem. You could think that the string has a length of 2 when actually it's 1 character. Or you could ask it to split in characters and split in the middle, and obtaining 2 invalid characters, stuff like that. If you have to deal with, well, Greek is okay. Greek is in the first 16 bits. But if you deal with like Asia, it's going to be an issue. So we have \u curlies, where you can put the full code point in there, the one you see in the Unicode table or in your character picker in your OS. And we also have a code point at method that complements the charcode at method, which will go the full code point instead of stopping at a single 16-bit block. And we also have a /u flag for regular expressions, which changes the behavior of the character classes so they do not split in the middle of a code point. They are guaranteed to return code point. Now, length is a method that returns the amount of characters, not code points. So here it's going to say 2. There are a lot of ways of getting the real length. You could spread the string, because strings are spreadable on code points, and then count how many items you have. You could use a number of things, count the amount of matches in the result of a match or everything. If you really need the actual length in code points, there are ways. Length will not do that, though. Because if we change the semantics of length, we're going to break the web. That's the thing with JavaScript. If we make an incompatible backwards change, we'll basically break the web. People are going to be pissed. Where are you going to see your cat videos? So we can't do that. So we have to, when we make changes in behavior, we make them in strict mode compatibility, for instance, strict mode system, or in new syntaxes. Otherwise, we can't. The arrow function. So people going to ES2015 go, yay, arrow functions. It looks like lambdas in Java 8. Yeah, but no. Also, people think that those new functions are just like a shorter way and that they auto-bind. That's exactly not true. That's exactly the opposite of what arrow functions do. So, to understand arrow functions, I have to talk quickly about this in JavaScript. This. Who here has at least once been bitten by this in JavaScript? Yeah. Okay, the other ones, you can raise your hands now that people have admitted already, you know. So the thing is, people think that JavaScript has methods. It does not. JavaScript has 3 functions. That's it. Super democratic. It's just 3 functions. Functions are not inherently assigned to objects, except in ES2016 class methods, which there's actually some element to that. But otherwise, they're just there. Just, okay, they're on a prototype. Big deal. You know, that doesn't matter. It's just a function. And so, to make it super simple, in traditional JavaScript, there is no automatically assign this to a function, ever. In strict mode, this will actually be undefined in a function by default. Okay? There's one and just one case where this will be automatically defined for you. It's when you do what I call subject-verb complement. That is, when you do object, and you grab a method using that object reference, so dot something or square bracket something, and you immediately call it. with the parentheses. That's the one situation where JavaScript will say, oh, okay, so inside that method, this is going to be the object you used. And that's it. Every other situation, it's undefined if you're in strict mode. Otherwise, and that's the trouble, in the browser, if you're not in strict mode, it's going to be window. It's a really bad idea. Especially if you do stuff like delete this.navigator, you know, or stuff like that. It's not a good idea. Well, you deserve it if you did that, but that's okay. So, people keep putting a lot of loops. How many people here have written once in their life stuff like var that equals this? Yeah, before the for each callback or stuff like that. Or dot bind this. Yeah, which is terrible performance-wise. Well, row functions don't have that issue, but why? Not because they automatically bind, that's actually the other way around. Normally in JavaScript, as in every language, when suddenly in the parser sees identifier X, what does it do? It looks for X, what we call lexically, depending on the structure of your source code. It looks for X in local variables, then arguments, then the surrounding function, then the surrounding function, and so forth and so on, all the way to globals. Pretty much every language works that way. But there's a special case. When you're in a function declared with the function keyword, 4 identifiers have special treatment. This, can anyone guess another one? Arguments. Arguments is going to be dynamically the arguments you're called with. And then there are 2 new ones in ES2015 called new.target and super. Those have special preference. Those are reassigned at call time. That doesn't happen for anybody else, just those 4. What row functions do is that they don't reassign anything. So any identifier, this, arguments, news, whatever, will actually be looked all the way up your source code until you're in an actual function that was declared like a concise method or a function, and that actually had a this, and it's going to use that this. It doesn't auto-bind, more exactly, it does not redefine anything. That's the other way around. What this means is that you cannot use an arrow function when you need a specific this in there. Anyone here using like Mocha or Jasmine or Sign-In? You know that those sometimes require this to be something like this.timeout or this.stop in Sign-In Sandbox or stuff like that. You cannot do that with an arrow function. You will have to pass a normal function with the function keyword. You cannot use an arrow function as a constructor. It does not have a this. You cannot bind it. Okay? So be very careful. They're great for small predicates, you know. You can use like a fat arrow and just like a small for a map or a filter. They're awesome. You can use them for callbacks and for each when you're in a method. It's just great. But bear in mind that if your function actually needs a specific this, it cannot use an arrow function. Okay? Otherwise, they're super great. They're short. They can yield to some weird stuff. Anyone here using Redux? It's good, isn't it? Yeah. So Redux has the map state to props stuff for the React Redux binder. And map state to props takes the whole props and returns whatever you wanted from those props, right? The ES2015 canonical way of writing that is this. And when you come to ES2015 the first time, you go, what the fuck? A, arrow, A. What are you doing? Actually, on the left side, you're destructuring an object, and on the right side, you're sending an object back. And I have to put the parentheses around because if I don't, it's going to be the curlies for the function. So it's going to be a function that evaluates those 2 expressions and returns nothing. So mapping to undefined. So you have to be super careful. So it looks exactly the same syntax on both sides of the arrow, but actually 2 syntaxes do something completely different. It's okay if you write that in a more verbose, traditional way. You know, it's totally okay. I love doing that because I love looking at the befuddled look of my trainees, like, what? And then they, you know, they get it, and they can come back to their company and go like, oh, so good. You don't get that, you're new. Yeah, that's a very healthy attitude at work. Maps and sets. So we have new collection types as well. New collection constructors. Traditionally, we've used plain JavaScript objects as maps and sets, you know, key values. But it has an issue. First, keys are converted to strings, always. So 5 and quote 5 quote are the same key. And objects are just going to say object, object. So all objects collide. All DOM nodes collide by element type. So that's a really, really bad idea. So we have map now, which works like a regular map, like a regular object, except the types of the keys are preserved. That's the one difference. So you cannot just say dot something to write or everything. You have to use get and set. You have has to check for existence. And we intentionally call the property size instead of length, so that when you manipulate a map or a set, you immediately see it's not an array, because you're not using length, you're using size. And sets are pretty much like an array, except the values are unique. So you can add a same value as many times as you want, and you can build a set based on an array, and only the first time is going to be used, and it preserves the order of addition. So that's a great way, if you look at the last line, that's a great way of removing duplicates from an array. You just build a set of the original array, spread it into a new array, and there's your original one without the duplicates. And performance-wise, you can't beat it. So it's kind of neat, and for those of you interested in like keeping references to like DOM nodes, but wanting them garbage collected when they're not in the DOM and stuff like that, we have weak maps and weak sets that will release the reference when they're the only one with it, just like in Java. Asynchrony is easy. Promises probably only have like 5 minutes left or something. Have to be careful. No? 8? Oh, that's cool. Okay. Who here has heard of promises? Okay, promises are awesome. Use these. They're not just another way of writing callbacks. If you do that, you're using them wrong. Okay? Promises are not going anywhere. Maybe you heard about async await. We're going to talk about it. Async await is not going to replace promises. It is based on promises. Okay, so be careful. There are a lot of things that suck with callbacks, especially if you do node stuff, for instance. So you do a lot of callbacks based off networking or file system. Callbacks sometimes are not called because the event already happened and you register the callback after the fact. Callbacks sometimes are called multiple times instead of one because the underlying code is shit, basically, or because the network has hiccups. You know? Sometimes you've got like success callback and failure callback, and both are called because the code underneath forgot the return. And sometimes your callback is sometimes called asynchronously and sometimes synchronously because it was in the cache. And that's a nightmare for your code because exceptions don't work the same way, workflow doesn't work the same way. So exceptions fix all of this. All the new APIs are promises. Sorry. All the new APIs are based off promises. All the new web APIs use promises. Fetch, service workers, streams, push, notifications, battery, and so forth and so on. Node is seriously considering providing a built-in promise-based alternative to its callback APIs like file system and network. And promises are really cool. I'm going to go fast. You can go through the slides, and also I have a link on the tutorial. There's an absolutely great tutorial by Jake Archibald on HTML5 Rocks. There's also a Node School workshopper called Promise It Won't Hurt. It might have a Greek translation. I'm not sure. I'll check. And it's really, really good. It's a complete course on promises where you prove yourself all the items in the spec by writing code. But promises let you chain asynchronous behavior in an easy way. You can inject your custom behavior in the middle. You have guaranteed capture of exceptions. So you can do stuff equivalent to catch and finally and everything using promises. Here's catch. You should always end with a catch, honestly, always. If you don't, especially in Node, you're going to have a warning in your console. Same thing in the browser. You're going to have what is called an unhandled rejection, which is what a lot of geeks face in high school. And there's a great visual playground for this called Promise Scenes by Daniel Bevacqua, the guy behind ponyfoo.com. And you've got details and an excellent tutorial on HTML5 Rocks. Seriously, if you haven't really got into promises yet, do it. It's super important. Now, the holy grail is coming, like for real, like it's in there already. It's already pretty widely supported. It's async/await. This is something we shamelessly actually, ripped off C# 5.0, which, as its name implies, was released in .NET 4.5. So the idea is that we want code that looks synchronous, because it's easier on the mind to have your for loops and your whiles and your ifs and your map and try catch, and all of that is much easier than callbacks and promises to look at and to understand. But we want all of this to be non-blocking. to be asynchronous. So it's sort of like, you gotta choose, except you don't. Async await lets us write code that looks synchronous, that is actually non-blocking. So it's like the best of both worlds. You can actually have your cake and eat it too. What you do is like you declare your function as async, using the async keyword in front of it. Obvious. And then in there, you just write regular code, except whenever you're about to call something asynchronous, you await it. And what that does is that's going to suspend your entire function execution frame, just like coroutines in Go, for instance, or in Erlang, and which is a really great thing. And it's going to suspend it, and your runtime is going to be available for any other processing that needs to be doing. And when that asynchronous operation ends, either in failure or in success, it's going to unfreeze as soon as it can. And if it was a success, you're going to get the result as the await expression. And if it failed, you're going to get an exception being thrown, which can then catch the regular way with a try catch, or let it propagate. And this is not Java. You don't have to put like 16 lines of throws at the beginning of your function. For one line of code. Fun, not fun exception, IO exception, and so forth. Good times. So that's great. This is, for example, the way to chain animations. Usually it's a nightmare. You have to listen to the current one's animation end event and then start the next one and propagate failure. Here's just a for loop. That's what it is. It's a for off loop, which is a way to iterate over any sort of iterable. So it's an actual legit loop on an array. It's super easy. That code reads like a regular synchronous code, except it's asynchronous. Let me show you another example. This would be in a Node server request handler. I could do like a number of what we call a waterfall, so a number of asynchronous operations that each need the previous one to complete first. And usually you would use async.waterfall or a promise chain, and here you just write those lines and just await anything that actually returns a promise. This could be a generator, this could be an async function, this could be a promise. And you just await them, and it just reads from top to bottom, like your programming 101 classes. It's even better because when we do that in regular languages like Java or any blocking language, so Java, Ruby, Python, C#, well, C# you can do that, but we write these sequentially. So request A, request B, request C, which is a shame because sometimes those database requests don't care about each other. They're completely orthogonal, and the fact that we have to put them in sequence instead of parallelizing them is too bad, really, because we're going to wait for the sum of all times instead of the longest of the times. But these are promises under the hood. So you can combine promises the usual way, like with promise all, and just await the combined promise. And this way, you're only waiting as long as the longest of the requests. And suddenly, your database, your server response, instead of being like, 250 mils, it's like 80 mils. So you can take a lot more workload. So that's just, async await is awesome. Again, links on various presentations and stuff that do a great job of showing them off. Just look at it, it's great. And it's natively supported right now in Chrome 55, in Edge 14, and it's coming up in Node 7, which is going to be released next week. So it has native support, and in the meantime, Babel can transpile it for you. So it works on line 9. Isn't that great? You do have to support IE9, right? No? Oh my God, you went from like IE6 to like Edge 12 in terms of support? That's awesome. That's great. Greece is way ahead. Okay, finally, very quickly, we have actual modules. That's the part that is not natively implemented yet. That's the part that you need Babel for, or Webpack. But that Webpack is going to use Babel. Same thing for Rollup or whatever. We have actual modules. They're great. They're amazing. They have static definitions, so statically analyzable definitions for exports and imports that do not have an issue with circular dependencies because they export what we call live bindings. They're really readable. They're really useful. We can use them interchangeably with Node modules right now, and we can load them asynchronously. Metaprogramming is great. You'll look at the slides. I'm running short on time. I'd like to see a couple questions. Here are a few links for further information. Okay, Christophe. Those are the links. I knew this was a bit too much.
Thank you, Christophe. Yes, we have time for 0 questions.
Yes. I'll be at lunch. Come and talk to me.
There is a lunch break coming up now. Yes, thank you very much.